And welcome to lesson 10.5, day 2. Today we're going to talk about segments that intersect outside of our circle. So again, non-parallel segments that do not intersect inside of our circle. But can be extended to form segments that intersect outside of the circle. And these are going to be our examples for today. So if we look at this picture here, we see the sides AB, okay, that segment. If we multiply that by the whole piece AC, it's going to actually equal the outside piece here, AE, and then times the whole piece on that side, AD. So a lot of times what we like to say is the outside piece times the whole thing on one side will equal the outside piece times the whole thing on the other side. So in examples down below, we see a couple of these. So notice our outside piece on this first one is QR, which is 5. And the whole piece here, P to R, is 9. So we're going to multiply those two together. And then we're going to do the same thing here with our outside piece RS. That's 3. That's going to equal the whole piece here. Now notice the whole piece is going to be the TS length plus the RX length, so X plus 3. So as we start simplifying, we end up with 5 times 9, which is 45. On the left, distribute the 3 to both pieces. We get 3x plus 9. Subtract the 9 from both sides, and then divide by 3. X is going to be 12 on this first one. So again, in the second one, again, we see this example here where we have the outside piece is 2, and then our whole piece, P to R, we're going to take that PQ segment, 4x, and we're going to add to it the QR, so 4x plus 2 would be the whole segment. On the other side, we have a piece that is 4 on the outside, and then that whole segment would have to be 5 plus 4, which is 9. So start solving. We need to distribute the 2, so it becomes 8x plus 4. 4 times 9 is 36. Subtract the 4 over, we get 32. X is 4 on our second example. Our third example, okay, they are giving us that we have an outside piece on this first one of 7. And then the whole thing, again, we need to add together the x plus 1 and the 7. So that's actually going to end up being x plus 8 when that's all simplified. And then on the right-hand side, we have 8 as the outside piece. And then again, the whole thing would be the x minus 2, but plus that outside piece of 8. So inside plus the outside to get the whole thing. So that's x plus 6 when we simplify the negative 2 and the 8. So that's our whole piece. Distribute on both sides this time. We have 7x plus 56 when we multiply. 8 times x is 8x. 8 times 6 is 48. I'm going to subtract the 7x first since it's smaller than 8x. And then I'm going to subtract the 48 so that x this time ends up equaling 8. Now there are 2 examples for you to try below. Reminder, when you are solving on these, you want outside times the whole thing. So remember, you are adding those pieces together to get the whole thing. And then same thing on the other side. You will need outside whole thing. And then example 2, we have outside whole thing and then outside whole thing. On the back, we also have another setup where sometimes we are going to be given these problems, and when we have our segment drawn on the outside, it's a tangent, and then there is going to be a secant. So in this case, when we have the tangent segment, we end up having to square that tangent segment, and then it's going to equal the outside times the whole of the secant segment on the other side. So in this case, we would have wx squared, and that's going to equal wz, that outside, times the whole thing, wy. So think about that outside segment is also the whole segment with these tangent secants. So on this one, we have our tangent segment that we're going to square, and then that's going to equal our outside segment times the whole thing. So that's 12 for our whole segment. And this time then when we start solving, we have x squared equals 36. And then we're going to end up square rooting to get our final answer here of x equal to 6. On the second example, we have on the outside our tangent segment is 8. So that's squared. And then we're going to equal outside, which is 4, times the whole thing, which is going to be x plus 4. So we end up with 8 squared, which is 64, and then distribute. 4 times x is 4x. 4 times 4 is 16. Subtract the 16 over. We end up with 48 equals our 4x. Divide by 4. X is 12. And then last but not least, we have 6 on the outside here. That's going to get squared. And then we have 2 on the outside. And then the whole thing this time is 2 plus the x plus 6 for a total of x plus 8 when we simplify. Distribute to both pieces. 6 squared is 36. Distribute, we have 2x plus 16. Subtract the 16 over and divide by 2. X is 10 on that last example there. There are 2 examples now for you to try. Okay, this first one, we have given the tangent is 24, outside is 18, whole thing. Second one, you are given tangent, and then they are giving you outside, whole thing. One final example deals with our tangent secant segments again, but this time we are trying to figure out how far away that Kip's house is from McDonald's is from Dunkin' on our walk to there. So here's Lloyd's house. This is the outside segment, which is 4 squared. And then we know Kip's house would be the outside piece here to McDonald's is 2. Whole thing would be x plus 2. So as we start solving here for x, 4 squared is 16. Distribute, we have 2x plus 4 over here. Plus sign. Subtract the 4 from both sides. We end up with 12 equals 2x. And then our x, after we divide by 2, is 6. So when the question is asking us for how far is Dunkin' from Kip's house, that's this whole distance, x plus 2. So we know that we're going to take our, to answer this question, we're going to take our x plus the 2, and we know that it's a total of 8 miles from Kip's house. So a long walk for that one. Thanks everyone for watching. We'll work more with these in class.